All right, so we know that gravitational potential energy is the amount of energy stored because of an object height above some reference point. It is energy, so we label it in joules. And I want to reiterate that the height is measured from some reference point that you choose. An obvious choice would be to choose the ground, but it doesn't have to be. Our classroom is on the second floor. It would be really inconvenient to have to figure out how far above the ground we actually are. And even if we choose the floor, if all we do is raise something off the table, it doesn't make that much sense to have to include the distance to the floor as well. So we're really looking at the amount of stored energy above some reference point. From our lab, we found that the amount of gravitational potential energy has to do with not only the height, but also the weight of our object. We are applying some force to move an object some distance, and in this case, we are moving the mass up against the force of gravity. So gravitational potential energy is the mass of the object times the gravitational constant times the height we raise it up. So say we have a 15-kilogram textbook that is sitting on a 1.2 meter tall table. If the book is lifted 0.8 meters above the table, how much gravitational potential energy does the book have with respect to the table? All right, so what do we know in this problem? We know that our mass is 15 kilograms. That's a big book. And we know that it is being raised to a height of 0.8 meters above the table, and the table is 0.12 meters off the floor. So which height do we want to use? The question is asking with respect to the table, so we are going to use the surface of our table as our zero height. This means the height we raise our book is 0.8 meters. We also know that the gravitational constant here on Earth is always going to be 10 newtons per kilogram, so we can use that as one of our knowns always. So we know that gravitational potential energy is found by taking the mass times the g times the height that we raise the book. So 15 kilograms times 10 newtons per kilogram times 0.8 meters. This gives us 120 joules of energy stored in the book because we raised it 0.8 meters off of our table. Now, what if we take the same problem and determine the energy with respect to the floor? Instead of saying we raised the book 0.8 meters, now we are including the height of the table as well. So the total height of our book is going to be the height of the table plus the height above the table, which would be 0.8 meters plus 1.2 meters, or just 2 meters. Plugging that into our equation for gravitational potential energy, we find the book has stored 300 joules of energy. We can also work backwards a little bit. Take a 4.2 kilogram basketball. It is shot towards the basket, and it gets stuck between the rim and the backboard. If it is found to have stored 160 joules of energy, how high is it off the ground? Here we know the amount of energy, and we are trying to find how high the ball is above the ground. So a little bit of algebra in our GPA equation shows us that the height of the basketball is equal to the amount of energy it has stored in it divided by the mass and the gravitational constant. Now be sure when you put this into your calculator that you remember order of operations. There are two numbers that we're dividing by. One way to do this is to type in 160 joules and divide parentheses 4.2 times 10 close parentheses. The other way is to divide 160 by 4.2 and then divide the answer by 10. Either way, you should get the height of the ball to be 3.8 meters. So on your note sheet, you have problems 7 through 12. Here are your answers. They are due tomorrow.